Welcome to math class where math makes sense. That's the goal. Welcome to math class where math's our friend. Come feel the math love. Absolute values. For absolute values, take what's inside. It's either equal to or opposite the other side. Let's break that down. For absolute value, take what's inside. Okay, so the 2x minus 8, it's either equal to or opposite meaning -4, the other side. The absolute value, take what's inside. It's either equal to or opposite the other side. Okay, well, why is that? Absolute values are the distance from 0. So if you're talking about the distance, remember, if we plug something in, if it's positive, it's just itself. So if 2x minus 8 were to equal 4 in here, then I'd get a true statement. If what's inside here was -4, then the absolute value would make it 4, and I would get a true statement. So what's inside is either equal to the 4, in which case, if this is 4, I'd get 4. Or if this is -4, I would take the absolute value and get 4. Okay, distance from 0, +4 and -4. +4 and -4, they're both 4 units from 0. So the absolute value always gives us that positive. It gives us the distance. There's lots of different ways to think about this stuff, and everything has to be consistent in mathematics. Okay, so it's equal to 4 or -4. And really, we're getting two basic equations. That's right, you get two simple equations from that definition of the absolute notation. All right, we're to solve them. Watch those signs for balance, make it opposite on the other side. I get the plus the 8, so 2x is 12, or x is 6. Over here, it's a -4, so the -4 plus the 8, so 2x could be 4, or x could be 2. Again, let's plug those back in and make sure it all makes sense, right? Why do I get these two different equations from it? Why does that happen? Because if I plug in 6, I get 12 minus 8, that's 4, and the absolute value of 4 is 4. If I plug in 2, I get 4 minus 8 is -4, and the absolute value of -4 is 4. Okay? So the absolute value, take what's inside. It's either equal to or opposite the other side. That's right, you get two simple equations from the definition of the absolute notation. Now, these ones are linears inside of the absolute value. Doesn't really matter what's inside the absolute value. The same thing works over and over and over and over again because it's based on this definition of this notation. So this were a quadratic or a cubic or a sine function, or you can always say it's equal to or opposite that other side. All right, let's keep going with this. We know that our answers are 6 and 2. If I wanted to look at this graphically, I can graph both sides. Yeah? So we'll call this the orange side here, and we'll call this the blue side, and I'm looking for where the orange equals the blue on my graph. Okay, so here's the part of the song that talks about the graph. The absolute value is positive. What's below the x-axis, which is negative, gets reflected. So the absolute value is positive. So if I had some sort of graph like this, if I took the absolute value of it, what's below the x-axis gets reflected. And I would say, I don't want this part, I don't want this part, I want to reflect it all up. Whoosh. Below the x-axis is negative. If I take the absolute value, whoosh, it reflects it all up. That's really how it works. Okay. The absolute value is positive, so what's below the x-axis gets reflected. That's right. Just graph what's inside the notation. Then flip the bottom part up for the absolute equation. Okay, that's right. Just graph what's inside the notation, 2x minus 8. I'm going to graph that. Negative 8 is down here. I'm going to go up up 2 over 1. So let's do this. Well, up 2 and up 2. So this is 6 and this is negative 4, negative 2. Okay, and so I'm getting like this-ish from my line, okay? All right, up 2 over 1. There is my line. All right, where does it cross this x-axis? It crosses the x-axis at 4. If I plug in 4 here, I'm going to get 8 minus 8. 1, 2. My graph's a little off. Sorry, friends. You know, it's just a sketchy sketch. Okay, so this is down at negative 8. This is at 4. All right, that's a little bit better. You should really use a straight edge. I'm just doing a sketchy sketch. All right. That's right. Just graph what's inside the notation, then flip the bottom part up for the absolute equation. All right, this part gets flipped up. Now, this is my beautiful absolute value v. The absolute value of a linear like this is a lovely v. We're wondering when it's equal to, this is the whole orange function now. Here it is. And we're wondering when it's equal to 4. So I could graph, if that's 8, I'm doing this kind of, here's my 4. This is the graph of 4. It's this horizontal line here. You see how I'm getting these two values? Well, the two answers are 2 and 6. It's happening at 2 and at 6. That's where they intersect. Okay? That's where they intersect. Visually, that's what's happening. We could go into more about how we can graph the absolute value. You know, we could do it using transformations, all sorts of things, but generally speaking, anytime you have any sort of graph, if it's a sine function, a cubic function, a tangent function, it doesn't matter what function is inside the absolute value. Graph what's inside and flip the bottom part up for the absolute equation. That's it. Now, one way to graphically look at, like if we did extend this part down here, right? Then notice that when I'm saying it was equal to the 2x minus 8 was equal to the 4, or the 2x minus 8 is equal to the negative 4, that's got to make some graphical sense too. It's equal to the 4, so this one, where it's equal to the 4, is this point right here. And where it's equal to the negative 4, I could graph negative 4 down here. And that, you see how it's happening right at that same x value there? So that, let me color code, this one where it's equal to negative 4 is this, right there, that intersection point. Okay, so we can either look at that absolute value graph in orange and say, where is it crossing 4? That's the original question. When I split it into two different equations, then I'm saying, oh, it's going to be equal to 4 or negative 4. And here you get those 2 points here of intersection. Everything has to be consistent in mathematics. It doesn't matter how you look at the problem. Put the pieces together and see that everything has to be consistent in mathematics. All right. Subscribe, follow along for more sense making of the mathematics. This song, which was called Absolute Value, is on Funky Functions. Stream it now wherever you get your music. Until next time, remember, math loves you. Bye.